Let's answer the remaining question. So exercise 1. I'm writing molecular formula, calculating valencies, and using oxidation number. Question A says that we should write the molecular formula of the tetraisotrophy 6 of ion 3. So we want to write the molecular formula of ion 3 tetraisotrophy 6 Fe3 plus SO4 2 minus. From charges, I'll write valencies 3 2. To form the molecular formula, I'll exchange valencies. So I'll get Fe2SO4 3. This is my molecular formula of ion 3 tetraisotrophy 6. Here, the molecular formula of ion 3 triazonitrate 5 will also be done the same way. Ion 3 Fe3 plus triazonitrate 5 anion is charged -1. So from that, I'll get their valencies 1, 3. Swap the valencies Fe1 NO3 times 3. So that gives me FeNO3, this molecular formula. Next is ion 3 triazocarbonate 4. The triazocarbonate 4 anion is CO3 2 minus. Ion 3 is Fe3 plus. So from these charges, I'll get their valencies. From 3 plus, I'll get 3. From 2 minus, I'll get 2. I'll swap the valencies to form the molecular formula, and my answer will be Fe2CO3 3. Please take note of that. Next is ion 3 hydroxide. Ion 3 is Fe3 plus. The hydroxide ion is OH minus. So from the charges, I'll get their valencies. From -1, I'll get 1. From 3 plus, I'll get 3. Fe1 OH3. I don't need to write my 1, but I need to keep these 3, so I can write Fe OH3. OH will remain in bracket. Take note of that too. Ion 3 chloride, Fe3 plus Cl minus. From charges 1, 3, Fe1 Cl3. I'll throw the 1 away to get FeCl3. F is ion 3 oxide. Ion 3 is Fe3 plus. The oxide anion is O2 minus always, except in peroxides. So from the charges, I'll get valencies. I'll swap valencies Fe3 O Fe2 O3. So that gives me Fe2O3. That's the end of question 8. Question 9 says I should write the molecular formula of zinc tetraisotrophy 6. The zinc ion is the positive ion in the compound Zn2 plus. Its valency is 2. The tetraisotrophy 6 ion has a net charge of 2 minus, so its valency is 2. I'll swap valencies to get Zn2 SO4 2. In this compound, my 2's are removed. The double 2's are removed, so you get ZnSO4. Next is zinc triazonitrate 5. Zinc is Zn2 plus. The triazonitrate 5 anion is NO3 minus. 1. From the charge, I'll get its valency. From the charge, I'll get its valency Zn1 NO3 times 2. So you get Zn1 NO3 2. You throw the 1 away, but you should keep the brackets and the 2 outside NO3. Zinc triazocarbonate 4 is next. This compound, zinc triazocarbonate 4, is made up of the cation Zn2 plus and the anion CO3 2 minus. The triazocarbonate is charged 2 minus, so its valency is 2. Zinc is charged 2 plus, so its valency is 2. I'll swap valencies, get Zn2 CO3 times 2, Zn2 CO3 times 2. So my compound, in this compound, the 2 on each side is removed, and the bracket will go with it here. So I'll get ZnCO3. Take note of that. Zinc hydroxide, Zn2 plus OH minus 1, 2. I'll swap Zn1 OH2. I'll throw the 1 away, get ZnOH2. Zinc chloride in E, Zn2 plus Cl minus 1, 2, Zn1 Cl2. So my molecular formula is Zn1 Cl2. We don't write our 1, so that will disappear. I'll get Zn1 Cl2. Zinc oxide has 2 parts, the cation part and the anion part. This is not a peroxide, so oxygen here, the oxide ion here will be charged 2 minus. Oxygen is always charged 2 minus, except in peroxides. So its valency will be 2. From the charge, 2 minus, I'll get its valency as 2. And Zn2 plus 2 has a valency of 2. So Zn2O2. Each of these will be removed. I'll get Zno. That's question 9. Question 11 next. Calcium, hydrogen, triazocarbonate 4. Calcium here, then hydrogen, triazocarbonate 4 is the anion. Hydrogen triazocarbonate 4 is HCO3 minus. So its valency is 1. Calcium is 2 plus, so its valency is 2. I'll swap valencies. Get what? Ca1, HCO3 2. I'll remove the 1 to get CaHCO3 2. B, 11B is lead trioxonitrate 5. Lead is Pb2 plus. The trioxonitrate 5 anion is NO3 minus. So 1, 2. This gives me Pb1. I'll swap valencies. Pb1, NO3, 2. So Pb1, NO3, 2. That gives me Pb, NO3, 2. I don't need to write the one. Zinc tetraoxosulfate 6. We did this before. Zn2 plus SO4 2 minus. So from the charges, I'll get the valencies. Oh, I didn't even remember to write the valencies, but I'm sure this is clear. Zn2 SO4 2. Each of these 2 is removed, and the brackets will not be needed too. So you get Zn SO4. D, 11D, ammonium hydroxide. The ammonium ion is charged plus 1. The hydroxide ion is charged minus 1. So from plus 1, I'll get 1. From minus 1, I'll get 1. I'll swap valency, so I get NH41, OH1. NH41, OH what? 1. I don't need to write the 1, so the brackets and the 1 will go. Ammonium hydroxide has this molecular formula. In 11E, sodium sulfide. Sodium is charged Na+. The sulfide ion is charged S2 minus. So 2, 1. I'll swap valencies. I'll get what? What will I get when I swap valencies? Sorry. What will I get? Excuse me. I'm on question 11. What will I get when I swap valencies? I'll get, Na1. Let me go back here. Na2, S1. So I'll get Na2, S1. That gives me Na2S, because I don't need to write that one. F is aluminum chloride. Aluminum is charged 3 plus. Al3 plus and Cl minus come together to form this compound. 3 will be the valency of aluminum. 1 is the valency of chlorine, so Al1Cl3. Al1Cl3 will give me AlCl3. I don't need to write my one. Zinc chloride. Okay, in question 10, that's the end of question 11. This brings us to question 10. In question 10, I'm to write the valencies of each of the elements underlined. In A, zinc is underlined. This compound is actually Zn1Cl2. So it is swapping, or it is exchange of valencies that brought it here. That means that this one is actually for chlorine, and this 2 is for zinc. So you write their, respective valencies out. That gives you your answer. Here, Cu is actually the owner of these 2, while OH is the owner of this one that disappeared here. So the valency of copper is 2, that of hydroxide is 1. Those are simple. In this one, we need an equation. The charge on this molecule is 0. So K2Cl2O7 can also be written as K2Cl2O70, meaning the total charge on the molecule is equal to 0. So if you put the charge of the 2 potassium atoms together with the charge of the 2 chromium atoms together with 7 oxygen charge, everything will add up to give you 0. Oxygen is minus 2. Potassium is plus 1. We don't know the charge of chromium. So I'll write this equation out like this and solve for Cr. So I'll get Cr from here as what? Plus 2 Cr minus 14 will give me, rearranging plus 2 minus 14 is minus 12, take minus 12 to the right, you get plus 12. 2Cr plus 12, Cr will be plus 6. So its charge is plus 6, its valency is 6. KMnO4 is done the same way. Manganese, potassium is plus 1, oxygen is minus 2. You solve for the charge of manganese and you get 7. So this helps us name this compound. This compound now, I would have named it potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7, meaning a potassium compound that has 4 oxygens, tetraoxo, and in which the manganate ion is charged 7+. So you will get to more of that later. Here, I'm just to exchange valencies. These three here actually belongs to ion. It was exchange of valencies that brought us to Fe2O3. It is the oxygen that owns the 2, and it is the ion that owns these 3. In compounds that are, having 2 elements most times like this, each atom always carries the valency of the next atom of its twin atom. So the valency of ion is 3, the valency of oxygen is these 2. So that gives us the answer to that. Each of these has a valency of 1, because although there was exchange, the values remain the same. Here, it is the oxygen that owns these 2. That's its valency. It was exchange of valencies that brought us to this N2O5, and it is the nitrogen. The valency of the nitrogen is this 5. So that gives you your answer. Here too, aluminum owns this 3, is charged 3+. Chlorine is the owner of this valency, this one that disappeared from here. So the valency of aluminum is 3. That of chlorine is what? 1. Here, we do the same thing as the previous one that involved calculations here. FeSO3 is the same as FeSO3 0. So put the elements together, you equate their charges to what? You equate their charges to 0. What does that give you? That tells you Fe. In this compound, this is SO3 2-. The sulfur there is charged +4. So Fe plus 4 minus 6 will give you 0. And that gives you what? The charge of Fe as +2. So its valency is 2. You do the same thing in lead triazonitrate 5. In lead triazonitrate 5, the charge of the NO3 minus is -1. So we solve for the charge of nitrogen the same way. Exchange will give us the valencies of phosphorus and oxygen here. And you do the same thing for FeO. You do the same thing for H3PO4. So that gives us the valency of each of the elements. It's a simple exercise, just like the first examples.